Hi everybody, welcome to part 4 of Measuring Your Gear with RumiQ Wizard. Location change, it's April 2020. I'm in quarantine, just like everybody else, recording this for you from my bedroom. But hey, what a great time to get to know your pro audio gear very intimately. And that's what we're gonna do today with Distortion. So, I've got my stuff all plugged in as I showed you in the first 3 videos. I've got a color palette set up to measure distortion, and I've got 3 different colors in there to see how they look on the graph. So the first thing I'm going to do is measure the palette with all the colors bypassed, just as our reference point. So I'm just calling this bypass, leaving the settings at the audible frequency range, 20 hertz to 20k, plus 4 dBu output. I push start, and what we're going to see here is a very flat frequency response and very little distortion, as you should with something that's not designed to distort. So since the color palette is just a host for distortion, it shouldn't have a whole lot itself. So I'm clicking on the All SPL tab to see the frequency response, and yeah, pretty razor flat distortion. This graph shows us the fundamental at the top, so the signal, and then all the different harmonics, as well as a different line for noise down here, and we're looking at, between minus 100 and minus 130 dB. So very little distortion, almost none to speak of. And a really cool thing about this graph is that as you click through the frequency response, it will tell you down here by each harmonic and by THD, total harmonic distortion, what percent it is of the signal. So super cool. And the noise floor as a percentage. If you want to see that as a decibel number, you click up here on controls. And for distortion figures, you do dB relative. And now if you click around, you'll see how many dB the harmonics are below the noise floor. So super cool. Still cannot believe this program is free. Okay, so I'm going to engage a color now. This is the CTX color. It's a discrete op amp with a transformer. So what we should be seeing here is a subtle amount, but visible, of distortion. And this is the kind of distortion you would see if you, for instance, ran a signal through a Neve mic preamp or through a Neve console or something. It doesn't have to be Neve, API, any kind of vintage console with those similar analog building blocks. Okay, so pushing start, we're going to see the sweep happen live here. And then we can compare this to the bypassed signal. Okay, so first looking back at bypass for reference, I'm on distortion here, and clicking over to the CTX, you saw all those lines jump up. That's our distortion. That's what you're looking at. And it's broken down by harmonic, which is so cool because that is where tone comes from. That is what the tone, kind of the sonic signature of different pieces of gear is, to be a little bit reductive. Different types of circuits create and emphasize different harmonics, and that's why an API sounds different from a Neve, etc. So a fun thing to do during your quarantine would be to measure all your gear and listen to it and say, okay, this one sounds this way, this one sounds kind of woolly and thick, and this one sounds bright and punchy, and then do a sweep like this and see if you can notice that. Is there more distortion in the upper mids, or is there more in the low end? That's the kind of stuff you actually should be able to see with this kind of graph, which is really cool. Okay, I'm going to show you one more way to look at distortion, which is with the generator and the RTA, which is the real-time analyzer. And the RTA, well, let's start with the signal generator. So I've still got the same CTX color engaged. So you set the frequency. I'm setting it to a sine wave. I'm putting it at, let's let's keep it at 100 hertz. Nice round number. It's a good low number too. There's more distortion at low frequencies. Did I just get a notification? Nobody read that. Okay, and plus 4 dBu. I push play on the signal generator and record on the RTA. And now it's showing me what's coming out of the CTX. So this big line here is our 100 hertz, as you would expect. And then these smaller lines are the harmonics. So 200 hertz, that's a second harmonic. 300 hertz, third harmonic, etc., etc. Now, if I take out the CTX, you're going to see a bit of a jump whenever you change something. So I'm going to go reset averaging, and now I have just that 100 hertz fundamental. Now let's try a different color. Let's try the TSX, which is a tube screamer distortion. And wow, okay, look at that. So here you can see, what would you infer about this color versus the other one? Well, it's a lot more aggressive. It has a lot more harmonics going on than that previous one, and that's going to sound like a lot more distortion. And as you go through and try out different things, another thing to look for is, are there more even or more odd harmonics? Different types of clipping will create even or odd. So here the odd ones are emphasized. In other types of gear, even will be emphasized. So that's a bit on how to measure the distortion of your gear with Room EQ Wizard. As you can see, there are really two ways. There's with this measure tool here. A Java error, that's fun. Or with the generator and the real-time analyzer. Both can show you the same information in different ways. So have fun with that. And yeah, leave a note in the comments if you have any questions or find anything particularly interesting. Thanks for watching.